So here we go. So my talk will be on Alice in Wonderland. So we will be going back to our childhood, and we will be doing this thing. So first of all, let me give you a little bit logistic thing. So here I try to put the preliminaries. So when you are working on your own, if you want to like get these like packages, you can import them from here. And basically, I will not go through these things because it takes a while to get all these libraries downloaded. And yeah, so and at the bottom of this notebook, you have extras and resources. Like I tried to put these extra resources and resources here. So again, if you want to go into this notebook and work on your own, it will be, I think you will find necessary information there. Okay, so what I am doing here. So let's dive into this problem. So I don't know you, but I have around like 20 minutes of commute every day, back and forth. It makes like 40 minutes. And I listen a lot of audiobooks, okay? I don't know like whether you are having the same thing. I listen at least an hour long, like everyday audiobooks. So, and I'm enjoying it. In fact, the only drawback I would say is I'm not reading that much book anymore. So this is the drawback. But I have an issue with the audiobooks. I'm sure you have the same thing. So let me describe what is the problem. So now I will bring you to Alice in Wonderland book, and we will start from chapter 1, and we will do a nice book reading club. So it will take a while. So let's go to Alice in Wonderland. And here, this is chapter 1, right? So in the PDF or in text, what I enjoy really is basically this thing. Okay, there was some orange marmalade thing here, I remember. Orange marmalade. If you can write. Also, like, I don't know why as a non-native speaker, I try to do this something like that, but bear with me. So orange marmalade, it just brings me there, and it tells me also how many orange marmalades are there in this text. So there's only one. Okay, cool. Let's look at what was the other thing in Alice in Wonderland? White rabbit, right? So white rabbit is definitely, there should be some white rabbit in this thing. So it looks like 22 matches. And in fact, in the first chapter, we have only 2. And I can go back and forth, okay? Now, my question is what is it, like a $1 million question, comes to the following. Now, here we have the first chapter of Alice in Wonderland, okay? Now, can you tell me where is orange marmalade, right? So I can play this thing.
Chapter 1 of Alice's Adventures in Wonderland.
But there is no way that I can find orange marmalade or like a white rabbit. I don't know.
I could if I only knew how to begin.
Where is it, right? So this is my problem. It is pain in my neck. I cannot go back and forth. And I was like killing myself. This is impossible. There should be a way to do this thing. And I kind of promise you that we will be doing this thing today, okay? So given an audio file, I will be given, tell me orange marmalade. I will be going to the orange marmalade, and I will be playing this thing for you. And in fact, I'm taking the challenge to another level, because if you give me the keyword as a text, this will be a little bit easier. And I will take the keyword as from your microphone, and I will detect this thing too, okay? So in order to be able to do this thing, we should first understand the audio files though, okay? So let's go into a little bit audio files and what are they? So audio files are basically a bunch of wave functions, right? So they are waves. And if you look at an audio file, you will see something like that. This is basically 6 seconds clip. And you might see here, there are like thousands are flying, because everything, and thank you, Nadia's talk, these are in milliseconds. So a second has 1,000 milliseconds. So I'm looking at 40 and the 46 seconds here. Now you can tell, like here, can you tell me what is going on here? Any ideas? Maybe you can write from chat or something like that. Any idea? Andy, you can chime in. What is going on here? So these are the loudness as I'm speaking, or as the speaker are speaking. And what about this part? So any idea if anyone wants to go ahead and tell me something? It's okay. Otherwise, I will go ahead. Cool. Let's see what are these things. So it looks like, okay, let's hear again.
And what out pictures or conversations. So she...
Did you realize what it might be? So at the end of the speech, speaker take a deep breath, and this is silence basically, right? So the other parts are to speech, and this part is silence. So my goal is basically, I was like, I can use this thing. How I can use this thing is basically, I can chunk my audio, basically, audiobook into silences, right? So into basically sentences and like silences and into sentences, etc. This is what we will be doing today, okay? So chunk, like dividing the chapter into chunks and indexing time steps. So if I can chunk my data into smaller pieces, let's say 5 seconds, then I can, if I can keep their beginning and end, I can easily jump from chunks to chunks, right? So this is the idea, but there is a catch here. So it will not be that easy, because if you go to uniform chunks, what will happen is the following. So here I am making 4-second chunk between 5 to 9 seconds, and I'm using a speech recognition package. Okay, there's a package called speech recognition, and they are using Google's speech recognition API to make the audio to text. So I'm cheating a little bit, but we will go back to this part. And given that 15-minute talk, I don't want to bore you with the machine learning part, but if you want, please ask, and we can go to machine learning part of it. So here I'm using off-the-shelf tool, which is speech recognition. It takes the chunk of the audio and it converts it to text. But again, the problem is more complicated than this. For example, here we have 4-second long audio, okay? Now we will hear it, and then speech recognition basically will convert it to text. But as you can see,
LibriVox recording. All LibriVox recordings are in the public.
So as we can see, because I chunk it in such a way that it's right in the middle of the sentence, it turns out that we, instead of LibriVox, we got box, and instead of public, we got pub. And if you search in Alice in Wonderland pub, it will be very inappropriate. I don't remember that Alice is going to a pub in Alice in Wonderland, okay? So this is not the case. What will happen is the following. If you search public, and if you go uniform chunks, unfortunately, you will not be able to find public, because we couldn't detect this thing because we chunked it from the middle of the sentence. So instead of doing this thing though, what we can do is basically we can go with the silence. Here I am basically in this cell, I am chunking my data into silences as I mentioned here. But there is another catch. Okay, there is silence here, but there are little silences everywhere. So even I'm talking, between even letters, there are silences, right? And machine can detect this thing. So what it means for silence. So in order to be able to chunk it, I am giving a certain amount of time to be able to count as silence. Here it is 750 milliseconds, so 3/4 of a second. If I get 3/4 of a second silence, this is for me silence, and I chop my data from there, okay? And what it means silence, how silence is the silence. For example, I will try this thing, bear with me again. Is this silence? Or is this silence, right? So the magnitude of the audio changes. So how much is the silence exactly? And here we are using -40 full scale decibel. It is basically, here we are using full scale decibel, means 0 is the maximum noise you can get. And basically anything less is negative, okay? So in this audio, for example, we had -20 decibel average, okay? So we counted here -40. And I'm padding each chunk from end and the beginning with some silent noise again, so that machine, if I give this thing to machine learning algorithm, it can understand the text very well, okay? So here it will basically, I give the local file. So if you again download from my GitHub, you will be able to get this thing also. And it will basically chunk my data into pieces, and it will return also the text. and start and end point of these chunks. Let me show you what I got here. So let me show you what I got. And I will be cheating here a little bit again. So in the audio chunks, let's see what is the second chunk, for example.
All LibriVox recordings are in the public domain.
As you can see, all LibriVox recordings are in the public domain. We hear all of the sentence. It's not divided in the middle. And this is basically 3 seconds. And the other one is 5 seconds because it's full sentence again.
For more information or to volunteer, visit LibriVox.org.
Okay, and I recorded everything in recognize.txt, and I can basically open this thing and make it bigger a little bit. So as you can see, for every chunk, I am basically recording the text that is spoken in this chunk. Now I will cheat very quick because I need the whole chapter and we don't have time for it. I will be moving them to trash. And I have saved data. I will be using this saved data basically to use. So they have all chapter chunks. And again, if you use my notebook, you will be able to have the whole chunk, okay? So here, I recorded also, I returned extracted text and it has this thing. So number of chunks, chunk 0, chunk 1, chunk 2, chunk 3, and their start and end timestamps. And what is in this basically chunk. Okay, let's go very quick. Basically, here I am getting the already prepared text. So finally, once I do this thing, in fact, basically I am delivering you the first promise. Given a keyword, let's say orange marmalade, I will basically go there very easily with these chunks, okay? Let's try orange marmalade. And I'm using fuzzy wuzzy match for this thing because like if I do string, like exact string match, it will be very complicated for me. Fuzzy wuzzy match is exactly what it is, sounds like basically. It makes a fuzzy wuzzy matches with the strings, okay? So I will be using this thing. If you want, I put the link also, the documentation of this library or package. So it is very easy library package, so you can easily use this thing in the string matches, okay? So goal is remember that there's only one orange marmalade and it should just start from there. I am searching in my audiobook right now.
Then she looked at the sides of the well and noticed that they were filled with cupboards and bookshelves. Here and there she saw maps and pictures hung upon pegs. She took down a jar from one of the shelves as she passed. It was labeled orange marmalade, but to her great disappointment, it was empty. She did not like to drop the jar, so she managed to put it into one of the cupboards as she fell past.
Okay, so then, okay, this is done, but the deal was I will say the orange marmalade and it will be basically like, tell me what's going on, right? So let's move to this thing. The real challenge is I will tell this thing and then you will be fine. And also there's another challenge. In the white rabbit, we can go the other ones, right? So I should be able to go to the next one. And when I want to stop, I should be able to say continue and it should continue. And it will basically do here, okay? And by the way, here, I'm getting late, as you can see, told the rabbit. So here, I am basically using the speech recognition again. There is nothing fancy. The only fancy thing is, again, both I'm using microphone and it has the dependency of Pi audio. Again, these are described in my notes. And I'm using speech recognition package. Speech recognition is using Google's API. So you need a key to be able to use this thing, but they are using public key. So I will not use this thing in my app because they can anytime revoke this thing and your app might not work. At the bottom of this notebook, again, I also showed how you can use Google's Cloud speech recognition algorithm and you can look at it, okay? So in order to be able to, we all use it here, I use this package, but otherwise you can use Google's also. So here, let's try. And again, given that I am non-native speaker, so machine doesn't understand my English is an already impressive thing, but let's see whether I will be able to do this thing. So here I'm running this thing and I will say the orange marmalade, it should go there and play it. Orange marmalade.
Then she looked at the sides of the well and noticed that they were filled with cupboards and bookshelves. Here and there she saw maps and pictures hung upon pegs. She took down a jar from one of the shelves as she passed. It was labeled orange marmalade, but to her great disappointment, it was empty. She did not like to drop the jar, so she managed to put it into one of the cupboards as she fell past.
Stop. So if it doesn't stop, I can basically stop it here. So it takes a while. And the second thing, the second challenge is, this is why also I'm stopping it. So I want to go with the white rabbit and I want to show you the other stuff. White rabbit.
So she was considering in her own mind, as well as she could,
as you can see, we find two results.
And stupid, whether the pleasure of making a daisy chain would be worth the trouble of getting up and picking the daisies, when suddenly a white rabbit with pink eyes ran close by.
Next. Oh, next.
Alice was not a bit hurt, and she jumped up in a moment. She looked up, but it was all dark overhead. Before her was another long passage, and the white rabbit was still in sight, hurrying down it. There was not a moment to be lost. Away went Alice like the wind, and was just in time to hear it say as she turned a corner, "Oh, my ears and whiskers, how late it's getting."
Continue.
Time to hear it say.
Now we will listen all of the Alice in Wonderland.
Ears and whiskers, how late it's getting.
So, okay. So as you can see,
she turns the corner.
When I decided to basically find, when I say, okay, I find the white rabbit, basically the place that I want to find. So I said continue, and we can continue for wherever we stayed. And right now it plays only 10 seconds, but we could continue this thing in this way. So here again, this is, I think, enough. I used all the all the resources here. And as I said, resources here, like I explained a little bit, what is the difference between decibel and like full scale decibel? What other packages we can use with Python to be able to manipulate audio files? How we use Spicy to make spectrograms. Basically, machine learning is done with the spectrograms. Again, if anyone interested, I can explain a little more. And all the speech recognition with Google APIs. Again, if you go here, you have the whole code to be able to do this thing. All you have to do is create an account in Google's cloud console. Okay, I think I'm done. I delivered my promises. Any questions? Okay, so we have. Sure. Do we have any questions? Taking a breath. Was I so fast? I'm sorry. Again, rabbit. So yeah, one question is 750 millisecond as standard thing. Okay, you got me, or basically it is not. So this is the part I did a little bit hand tuning, okay? But this is a further research thing. It can be easily, I couldn't find anywhere basically like automatically detect the silence period. So it is another good machine learning application, in fact, instead of, since right now silence detection is mechanical, right? So it looks at the silence, it takes the number of minutes. So there's no machine learning, there's no smart algorithm there. So it can be really, really good app, another application of machine learning, basically, if we can detect the silence by machine learning. Yeah, Google, I think Google Colab and microphone. Yes, there is one blog post, nice blog post. You can apparently use microphone with the Google Colab, but it is a little bit pain in the neck. I was thinking to first do this notebook in the Google Colab, and I realized that it is too much work to organize. But if you search, you can do this thing. So there is a way to use microphone from Google Colab. And here I am using Pi audio package to be able to get the microphone. It is a little bit, again, difficult to install, but you can figure out, again, look at my notes. So I cannot figure out, okay, where we left. Can I process microphone as an audio matching, not convert text? Okay, Juxia, I think if I pronounce correctly, this is also great. Yes, you can basically, without going to text, you can make an audio search, but this is a little bit difficult in terms of machine learning, but it is a good idea. In fact, I wanted to do the same thing, but you will need lots of labeled data, of course. For example, you cannot also home train a speech to text algorithm because it will take forever. Like you don't have this labeled data, and only Google or like Microsoft and IBM has this kind of this scale data. Another language, Google's algorithm is, I think, I will say, pretty much awesome in any language. They are doing a great job, I will say. They are supporting, I think, 7 or 8 languages right now, different languages, and they are doing pretty good job. And as you know, maybe you might use, I am using Pixel 3, and it automatically detects the language too. From English to Turkish, their machine learning algorithm can automatically identify the language, and then it continues in this language. It is pretty cool stuff, to be honest. And they owe this thing to their latest algorithm, as far as I know. Could you link to the speech recognition library? Yes, sure. And also, I linked my GitHub. Please look at there. There are, like, at the end, resources. They have all the links, basically, but I can also link here if you wish. Okay, I don't know, someone help me. So should I stop? If you don't let me, like, if you don't stop me, I can continue forever, so you should.
I think we're good. Yeah, we still have a few more minutes.
Okay.
We can keep going.
Okay, a text search from chunks is a good. Okay, can you explain the spicy for machine learning? Is this spicy, do you mean for NLP or, yeah. So I'm not using NLP here because I don't even need it. Another, again, further project might be take for example, in machine learning books, if I'm reading machine learning, let's say I wanna search for a context. So you can do on top of this app, you can do NLP machine learning, right? And then you can go to the context instead of go to a keyword. This is a basically direct search, but you can also do this thing. It will be cool. Again, like this is a very small basic algorithm or app, but there is a lots of improvement. And again, it will happen. I think this is, unstructured data is how things are going. There are lots of cool stuff is happening every day, basically. Can I press the microphone input as audio matching? Okay, so I answered. This is a freely available. Yeah, I checked Mozilla Deep Speech too, but I feel like the speech recognition packages, everyone can easily use it. I didn't check deep speech like on my own, but there are, yeah, I didn't use this thing on my own, but I will definitely check Mozilla's too.